Hello everyone, I'm Jivika Kanchella and I'll be explaining you guys the solving of second question in homework 5 of the course Probability and Stochastic Processes. Therefore, let's have a look at the question. Given the function f of x, y is equal to 1 by a into y squared x, where y value is greater than or equal to 1 and the value of x is between 1 by y and y. Therefore, we're supposed to find out four parts in this questions. That is, the first part we're supposed to draw the non-zero definition region of the function. We should find a such that the function is a valid joint density function. We should draw the marginal density functions for f of x and f of y, and also we're supposed to verify that f of x and f of y are the valid density functions. Now let's have a look at the solution for this question. Therefore, it is given that the function f of x, y is equal to 1 by a into y squared x, where the value of y is greater than or equal to 1 and the value of x is between 1 by y and y. Now in the first part, we are supposed to draw the non-zero definition region that will be equal to, that is x is equal to 1 by y, this will be the curve, and the value of x is equal to y, this will be the curve. Therefore, the shaded region here, as you can see in the graph, will be the non-zero region of f of x, y. Now in the second part, we're supposed to find the value of a so that f of x, y is a valid joint density function. If any function is a valid joint density function, the value the integral of that function will be equal to 1. Therefore, we'll be integrating this function x, y over x and y over the interval 0 to infinity, since it will be only a positive values that we see for x and y. Therefore, first let's take it over the interval 1 by y to y, since the value of x is between 1 by y to y. Therefore, we'll be taking it over the interval 1 by y to y into the function dx of dy equal to 1. Therefore, if we do the integral, we will be getting it the value as 1 by a into integral 1 to infinity by 1 by y square into log y minus log 1 by y. Now if again we will be integrating it for x here, with respect to y. Before we integrate it with respect to y, this is the equation that we will be getting, that is 1 by a 2 by a integral 1 to infinity log y by y dy, which is equal to 1. Now let us assume log y is equal to z, that is y is equal to e power z. Therefore, differentiating on both sides, we will get that 1 by y dy is equal to dz. Now therefore, we will substitute that here. We will get a by 2 is equal to z into e power z by e power 2z into dz is equal to 1. If we do the solving, that is the integration, we will be getting that the value of a is equal to 2. Therefore, that is the second part of the solution. Now in the third part, we're supposed to find out the probability, f of x is equal to we're supposed to calculate the value of f of x. Now let's consider it for the interval that x lies between 0 and 1. Therefore, minus infinity to infinity f of x, y dx will be equal to 1 by x to infinity 1 by 2 into y square x dy. Now since 1 by 2x is a constant, we will take it out. Now we will integrate y square 1 by y square, and then we will get the value as y power minus 1 by 1 from 1 by x to infinity. If we substitute the values, we'll be getting that f of x is equal to 1 by 2 over the interval 0 less than x less than 1. Now for the second interval, we will be calculating the value of f of x over the interval 1 to infinity. We will be using the same function, that is 1 by 2x will be a constant, so it will be out. Therefore, x to infinity 1 by y squared dy. Therefore, if we substitute the values, we will be getting that f of x is equal to 1 by 2x square for the interval 1 by 1 less than x less than infinity. Therefore, f of x is equal to 1 by 2, where 0 is less than x less than 1, and 1 by 2 into x square for 1 less than x less than infinity, and this will be the graph. Now similarly, let's calculate the value of y over the interval 1 less than or equal to y less than infinity. Similar case where 1 by 2 into y square will be out, it will be 1 by x dx, that is log x, that will over the interval 1 by y to y, which is equal to 1 by 2 into y square log y minus log 1 by y. If we do the solving, we'll be getting it as log y by y square, and this will be the graph for that. And the fourth part, we're supposed to validate that f of x is a valid probability density function. If any function is a valid probability density function, we should prove that its integral is equal to 1. Therefore, integral 1 to infinity f of y dy will be equal to 1. Now since we know the value of f of y is equal to log y by y square, we will be substituting that value over here, and then we will be getting it integral 1 to infinity log y into dy is equal log y into dy, and if we do the integration, we will be getting its value as equal to 1. Therefore f of y is a valid probability function. Now similarly, let's check it for f of x, and in the same way we are supposed to prove that the value is equal to 1. Therefore the integral in x, we have two intervals, that is from 0 to 1 to 1 to infinity, and we will be substituting those values respectively, that is these values, the 1 by 2 into 1 by 2 into x square values here. So it will be 0 to 1, 1 by 2 into dx plus 1 to infinity, 1 by 2 into x square dx. Therefore, if we substitute that, we will also be getting the answer equal to 1. Therefore, f of x is a valid function.